venture into quadratics. What we're going to do today is a particularly clever way to manipulate a quadratic into a form that we want. We don't have to let these numbers and symbols rule us. We are their masters. So we will do what we will and bend them to our wishes. So just quick recap from what we talked about in weeks prior. There are different ways that we can write quadratic. We discovered that if it's written kind of like this, what's called the intercept form, we can immediately see where that u-curve is going to hit the x-axis, or that is where y will equal 0. If it's in this multiplication of two binomials, then that m and n will be essentially the x-intercepts. We also learned the vertex form, that if it's in this, ooh, there's a typo. There we go. If it's in this form, then we discovered that the vertex is very obvious. It's just these two numbers, a and b. Remember, it's the opposite of that one, right? So that one was particularly helpful because I think the vertex for these u-curves is the trickiest bit. It's easy to find a symmetrical pair with some clever guessing, but finding the vertex takes a little bit more work. And again, I want to be as lazy as possible. And earlier, we discovered the perfect square trinomial, that if we happen to have a quadratic where the first and third term are both perfect squares, and the middle term is twice as big as the roots of those two squares, that's a very convoluted way to articulate it, then it can be factored to look like this, or those two. And since they are identical, we can just say x plus l squared is this perfect square trinomial. The only thing is that perfect squares aren't as common in the wild as we would like them to be. So the chances of coming across a quadratic that is a perfect square trinomial is kind of slim. What I like about today's method is that we're going to make them more common. We might come across a quadratic that looks something like this. Right? Now, if you try to factor that, if it is factorable, it's not going to be pretty numbers. I mean, there are only there's only one way to get 3 because it's a prime number, 1 and 3. So if we were to try to factor it, there's really only one option. But 3 is negative and this is positive, which means one's going to have to be positive, one's going to have to be negative, or rather, yeah, that's fine. But the product or the sum of 3 and 1 is not 10, so this actually is not equal to this quadratic. So factoring the way that we were talking about it earlier isn't going to work well. Because if it is factorable, it's not going to be nice, easy numbers to do so. So what can we do? Oh, that was supposed to be a y. What we can do is try to bend this so that it is a perfect square trinomial. Because if this can be written as a perfect square trinomial, then it's going to be a lot easier to play with, to graph, etc. So the first step, I've kind of actually already done it, is pretend for a second that y is 0. So set y equal to 0. Get rid of the y, and so set the whole thing equal to 0. Now, this is a perfect square. This is a nice even number, which is nice. But this is not a perfect square. If it was, though, then this would be a perfect square trinomial, or at least it could be. So the first thing we're going to do is take our c and put it onto the other side, but leave that spot blank. So that's x squared plus 10x. I'm going to leave a blank. I'm going to adding 3 to both sides. So by adding 3 to both sides, it's going to cancel out here, and it's going to pop up on this side. Excuse me. Now, we want to ask ourselves, if everything on the left were a perfect square trinomial, what would have to be right here? Okay. Well, we want these two to be identical. So it would be x here, x here. Since this is plus, we're going to make this plus and this plus. Okay, so the sum of these two numbers has to equal 10. Oh, that's easy. Then what's half of 10? 5. Right? And then obviously these are identical, so this is essentially x plus 5 quantity squared. Okay, now if this were a perfect square trinomial, we could make it look like this. So let's make it look like this. What would this number have to be? Well, if you multiply these out, you'd find out that for that last term of the 5 times 5, that's going to be plus 25. Okay? So at this point, this and this, well, and then also this, are all equivalent. We just bent this to fit the form of a perfect square trinomial. But in doing so, what we had to do was add 25 to this side. And if we remember, when it comes to equations, whatever you do to one side, you have to do to the other. So we're going to add 25 over here. 25 plus 3 is 28, so just to carry this down, 28. Okay, easy enough. Okay, so we've now twisted this uncomfortable quadratic into a perfect square trinomial and some other guy. But we wanted to get it back into that quadratic form, so we want to reintroduce y. And remember, at the start, we allowed y to be 0, so we need a 0 to substitute that y back in. So I'm going to subtract the 28 from both sides. So we have x plus 5 quantity squared minus 28 is equal to 0. But 0 is what I let y equal at the beginning, so I can then just kind of substitute y back in. And boom. We now have this quadratic written in vertex form. And you can see immediately that the vertex of this quadratic is going to be -5 and -28. It's pretty sweet, and it only took us like a couple steps. Being able to know the vertex in just a couple steps, that's way better than what we were doing before. And if you don't believe that this is right, you can multiply this out, and you'll get this original back. So what we've done is we forced this quadratic into this format that is called the perfect square trinomial, because perfect squares are really easy to work with. This method is called completing the square. And it's a very, very useful method. And in our next kind of section, we're going to see that it unlocks a very universal truth that is quite lovely. But that's one version of it. Now you get an idea of, we have an idea of what it is that we're doing. We're forcing a quadratic into the format of a perfect square trinomial, and then there's always going to be a little correction factor because that format is a little bit easier to work with. So let's try just one more, and then after that we'll kind of enumerate the steps so that we can kind of get the mechanics down. But it is important that we start with knowing what the heck we're doing when we're doing all these steps. Alright, so let's get another. How about this one? Alright. You probably see immediately that this is not going to factor, because there's only one way to get 1 times 1, and 1 plus 1 is not going to be equal to 4, so that's not going to be any help there. But if we complete the square, we can at least get the vertex, and that's going to be helpful for us. Alright, so step 1, I'm going to backtrack. Our real step 1 is to ensure that our A is 1. Now this didn't come up in the last example, but it is going to be an example, or it is going to be our real first step going forward. If a, the coefficient in front of the x squared term, is anything other than 1, you need to change that. And the reason being, when we have that perfect square trinomial, we can't really reduce it into this factored form unless a happens to be a perfect square itself. But then again, that would also impact the other square. Basically, if that didn't make any sense, don't worry about it. Basic rule of thumb, step 1, make sure that a is equal to 1. And it is 1 here, so we don't have to worry about that. Step 2, let y equal 0. Why? Because we can. Step 3, take c and put it on the other side, but leave that space blank. So we have x squared plus 4x blank. We're going to have to subtract 1 from both sides. So we get negative 1. All right. Now we have to ask the all-important question. If this were to look like a perfect square trinomial, in other words, if it were to reduce to this format, what must that number be? Well, we discovered last time that this number was exactly half of b. And then this number ended up being that number squared. All right, so what's half of 4? 2. And what's 2 squared? 4. So that is probably the trickiest bit because we're kind of working 2 lines at once. You have to think this number is going to have to be half of this, and then I'm going to have to insert the number back up here, and I'm going to have to square it. All right. But we just added 4 to the left side, so we're going to have to add 4 to the right side as well. Negative 1 plus 4, it's going to be 3. And looks like we're about there. Subtract 3 from both sides. We get x plus 2, quantity squared, minus 3 equals 0. But at this point, I'm going to reintroduce our y. This part does not erase. And we're good. And again, if you don't believe me, multiply this out, and you'll get back our original. And we can see immediately that the vertex for this quadratic is going to be negative 2, negative 3. If you don't believe me, graph it. All right. Hopefully that was somewhat clear. We're going to do one more example that is going to employ all the rules, and as we're going through the rules, I'm going to enumerate them on that far side of the board. All right. Step number 1. Make a equal to 1, unless it's already 1, then you're fine. In this case, it is not. In this case, it is not. It is 2. So we're going to have to divide boogers and toots. I misspoke. That is going to be step 2. We're going to let y equal 0 be our first step. Step 2! Make a equal to 1. All right, so first step, we're going to make y equal to 1. 2x squared plus 12x minus 4. Sorry, let y equal 0, I should say. All right. Step 2, make a equal to 1. So I'm going to divide everything by 2 so I can make this into a 1. Actually, I'm not going to number these steps over here because that might be confusing. Alright, so 2 divided by 2 is just going to be 1. So we're going to get x squared. 12 divided by 2 is going to be 6. And then 4 divided by 2 is going to be 2. And then 0 divided by 2 is still 0. Alright? Step 3. Take C and get it out. Get it onto the other side. So since it's minus 2, I'm going to add 2 to both sides. We end up with x squared plus 6x. Remember to leave a space. Is equal to 2. All right. Next step. Ask Ask yourself, what would make this perfect? And the way I like to do it is just below. Say that, or write it out as if it's already done. And the way to do this, I guess, so sub-step of 4. If I misspell anything, please forgive me. I'm going to take half of b and I'm going to put it in the parentheses down below. So half of 6 is 3. All right. And then the second part is to take that number and square it for my new c. So take 3, square it. 3 squared is going to be 9, so I'm going to add 9 to both sides. All right, then 9 plus 2, that's going to be 11. So I end up with this perfect square trinomial, x plus 3 quantity squared is equal to 11. Subtract 11 from both sides to get 0 on the right. All right. Get 0 on the right-hand side, so I'm going to subtract 11 from both sides, and then substitute y back in for the 0, and we're done. We now have the same quadratic in vertex form using this process called completing the square. So, 6 steps, not so bad. Hopefully that makes sense. But if it doesn't,
I can't help it, I'm alive. You brought matches, I'm on fire. Sunlight shivers, early light.